Okay, let's give you guys some more practice. So here you've got a circle of diameter A, and you're trying to keep track of this point P here, this point here, and the angle is always increasing. The angle is increasing, but the thing is, P is moving in such a way that this distance here is always equal to this distance here. So you're trying to keep track of P. So for example, if you draw a straight line here. Let's say if you draw a straight line here, let's look at this straight line here. Okay, this distance here will always be the same as this distance here. If you draw another straight line, let's say this straight line here, you see this distance here is quite short. That means that P here will also be quite short. If you have another straight line, so remember we're increasing we're increasing theta in this direction. So if you have this straight line here, then if you look at this here is the distance is quite long. So here the distance will also be around here somewhere. So if you have this distance here, you see this distance here is really long. So P would be the equivalent length, maybe somewhere around here. So this would be your P. So when you draw the path, it will look something like this. It will look something like this. Okay, so as you increase the angle, you can see the path is moving in this direction here. Okay, so if you were to increase the angle, if you were to increase this theta here, the path of P would follow this red line here. Okay, so come up with the so let me just summarize. All that you're given is that you're given the diameter, which is A, and you're given the angle theta. That's all that you're given. But then just remember that this distance here will always be the same as from P to the origin. Okay, so come up with the parametric equations to describe the path of P. Okay, so press pause and have a go. Okay, so to do this, hang on. So to do this, realize that, well, the hard part is in taking the first step. Visualize the center of the circle as being here, and this angle here must also be theta. So if you look, going back to here, going back to here, if you can, going back to here, you're trying to keep track of P. You're trying to keep track of P. So if you know this length here, remember all that you're given is a diameter, and the angle. If you can somehow keep track of this length here, then you can work out the coordinates, the x coordinate and the y coordinate. But working out this length here is the same as you working out this length here. Okay, so if you can find a way of working out this length, or find a way of working out this length here, then you can pretty much keep track of x, and you can keep track of y. But the next question is, how do you keep track? How do you work out this length given an angle? How do you work out this length? Well, to find that length, this is what you would do. Hang on. So to find out that length, so the center of the circle is here. If this here is theta, then this here must be theta, because if you look at this, you've got an isosceles triangle here, which is this triangle here. So this, hang on. So this B here would be this point here, and this is your center of a circle here, and then your D would be right here. So this is your isosceles triangle here, and the angle here is theta. Don't forget the length here is A over 2, which is this length here. So this length here must be this thing. Then if you want to know the whole length here, which is this whole length here, then it would be this times 2. So that would then give you A cos theta. So this length here, hang on, this length here is A cos theta. Now, if you want to find out this length here if you want to find out BC, then you would get the whole length here. You would get DC take away DB. So don't forget, we've just worked out that this length here is a cos theta. So that's this length here. Now the length DC would be given by us looking at the big triangle here. By looking at this big triangle here. Okay, so don't forget, this is our circle here. The diameter of the circle is A. So well, we can work out this. We can work out this length easily. So hang on, let's start again. So if we can keep track of this length here, then we can keep track. Then we can keep track of x, and we can keep track of y. Well, this length here, we're told in the question that is always equal to this length here. So to work out this length here, you would get the hypotenuse of the big triangle, take away BD. So hang on. So BC is given by this. BC is given by this. Okay, so hang on. Let me think about this. Hang on. BC. Hang on. Let me think. Sorry. So hang on. Let's start again. Sorry. BC. We're trying to work out BC here. So BC would be us getting the hypotenuse of the big triangle. So the hypotenuse of the big triangle would be would be us looking at this triangle here. So it would be cos theta equals A over, let's just call this I don't know, Z. So it would be A over Z. So if we want to work out Z, then we can times both sides by Z here, and then divide both sides by cos. So divide both sides by, so A over cos theta. So Z equals, so Z, we no longer need this letter now. We can just use the hypotenuse as this. So this hypotenuse would be this, okay? And then so this hypotenuse here would be this. And then now we need to take away this. Well, taking away this is this distance here, which is this. So BC, which is this distance here, is given by this. Tidy this up, and it will then take you to here. So now let me think. So now looking back at this small triangle, hang on. Now looking back, so we've now worked out BC. We've now worked out BC to be this. Well, BC, hang on. So BC is the same as this length here. DP is the same. So we now in effect have this length here. So with this length, we can easily keep track of x and y. So this here is a right angle triangle now. So looking at this small triangle here. So don't forget, we've got the hypotenuse of this small triangle. So we can easily keep track of so now we've got the hypotenuse here. We've just worked it out, and then now to keep track of x. Don't forget, we know what theta will be. Theta is moving about. We can keep we know theta. So the hypotenuse is given by this. So hang on. So sine the angle. So sine the angle is given by opposite, which is this bit here, divided by hypotenuse, which is this bit here. Tidy this up. That will then give you this, and then it's blah blah. X equals this thing here. So now we've got x. So now to work out y, going back to the same small triangle. Earlier we worked out that the hypotenuse is this, the angle is this. So we can always work out y. So now looking at y, so cos of the angle is adjacent over hypotenuse, Tidy this up, it will then give you this, and then blah blah, y equals this. So now if you punch this into your graphics calculator, x is given by this, and y is given by this. So as you increase theta, you have a way of working out x and y. So if you punch this into your graphics calculator, you will get this path here. Okay.